Hello everyone, this is Sharam from Learnacom. In this video series, we will delve into the fundamentals of industrial automation. We will explore the core concepts and technologies that underpin the automation of manufacturing processes. So get ready to learn about the building blocks of industrial automation. In this video, we review Programmable Logic Controllers or PLC. We look at the key components, benefits, how it works, industrial applications, and world-renowned vendors. Ever wondered what a PLC is? Well, it's a nifty digital computer that helps automate industrial processes like those cool machines on factory assembly lines. PLCs have pretty much taken over from the old school relay logic systems in industrial automation, and for good reasons. With PLCs, you don't have to deal with the mess of wires that relay systems need. Everything is managed through software, so it's way less complicated. PLCs are much smaller than those big, bulky relay panels. This means you have a lot of space and you can use control cabinets more efficiently. PLCs come with a built-in diagnostics that makes finding and fixing problems a breeze. No more manual checking like with relay systems. The best part about PLCs is that you can make changes through software. No need to rewire anything. This makes updates and modifications super easy and cuts down on downtime. Let's talk about the key parts of a PLC. CPU is the brain of the PLC. It handles all the processing and makes decisions based on the program instructions. Input-output modules are the connectors that link the PLC to the real world. They connect to sensors and actuators, letting PLC receive inputs like temperatures reading and send outputs like turning on a motor. You may deal with 4 different modules, including digital in and out, plus analog inputs and outputs. Communication interfaces are used to connect the PLC to other devices and networks. Most modern PLCs use Ethernet, but you might also see serial interfaces like RS-485. These interfaces help the PLC communicate with other systems to keep everything running smoothly. Here is how a PLC gets the job done. First, the PLC receives signals from sensors. These inputs could be anything from temperature readings to the position of a switch. Next, the CPU, or the brain of the PLC, processes these inputs based on the program it's running. It decides what needs to be done. After processing, the PLC sends commands to the actuators. This could mean turning on a motor, opening a valve, or any other action needed. The whole process of reading inputs, processing the logic, and updating the outputs happens in a cycle. The PLC cycle time is how long it takes to complete one full cycle. The faster the cycle time, the quicker the PLC can respond to the changes. Now let's dive into PLC programming. First, you write the control program. This involves creating the logic that tells the PLC what to do. After writing the code, you need to test it to make sure it works as expected. Debugging is part of this process, where you fix any issue that comes up. Before you run the program on actual hardware, you can simulate it. Simulation lets you test the program in a virtual environment to see how it behaves without risking any real equipment. There are a few different languages you can use for PLC programming. The most common ones are ladder logic, function block diagram, and structured text. Each has its own style and use cases. Every PLC vendor provides their own development tools. These tools can be installed on a regular PC, allowing you to write, test, and debug your code. Once everything is ready, you load the program into the PLC's CPU. Now let's look at some real-world PLC applications. PLCs are everywhere. They are used in manufacturing assembly lines and robots, in utilities like water treatment plants and power stations, and in production machines like bottling and packaging. And last but not least, let's talk about some top PLC vendors. Number one worldwide is Siemens with the famous Simatic family. After that is the Allen Bradley's Control Logic series, which is the market leader in North America and is popular for its ease of use. Schneider Electric Modicon series is also renowned for its reliability and advanced feature. Okay, that was a quick intro into the PLC topic. If you found this video helpful, please subscribe, like, and share. Thank you for watching this video and see you next time.